Hello friends, we are going to solve the very first problem from the book I.E.Irodov, that is the author I.E.Irodov. The book is called Problems in General Physics. It is a very famous book, especially for IIT JEE preparation. It has a lot of very good and interesting problems in physics, basic physics actually, at the 11th and 12th standard level. So let's get going. So we are told that a motorboat is going downstream and it overcame a raft at a point A. So a raft is like a log of wood which is floating with the water uh, at the speed of the stream. So tau equal to 60 minutes later, it turned back and after some time passed the raft at a distance L equal to 6 kilometers from the point A. So find the flow velocity assuming the duty of the engine to be constant. So we are supposed to find at what speed the stream is actually flowing. So let's quickly draw a diagram. Suppose this is the direction of the stream, and this is the direction of the stream, and suppose u is the speed of flow. It's also called flow velocity, or let's call it flow. So we are told, or we have assumed that the stream is flowing at the speed of u towards the right. And we have the motorboat that, let's say it's initially at point A where it overtook the raft. Okay, so this is a position at t equal to 0. The motorboat and raft are both at this particular point. So then they start moving along the river, and the motorboat went up till say a point B, and this was at time t equal to tau when it took a turn and it started flowing backwards, and then it came to a point C. Let's say whatever be the point C, let's assume it's all in the same line. It came to a point C at say a point at a time t equal to t1, starting from the beginning, when again we have the motorboat and raft. So this is, at this point we have the motorboat only. So we want to find this velocity u. So let's assume that v is the speed of motorboat in still water. In still water. What that means is that when the stream itself is not moving, the motorboat will be able to move at v km/h. However, when the stream is moving, and say the motorboat is moving downstream, that is along the stream, the speed of the stream will add to the speed of the motorboat, thereby increasing the speed of the boat. And we are told that the duty of the engine is constant. What that means is the engine is applying, in simplistic terms, equal force or equal push to the motorboat. So in still water, if it is moving at v, even in the flowing water, the engine will put the same push to the boat, and since the stream itself is moving, the speed of the motorboat will increase by that amount. That is the speed of the stream. So that way we can write that v plus u is the speed of motorboat when moving downstream, and when the motorboat is moving against the stream, the speed of the motorboat will decrease because the stream will be trying to push it backwards. So the speed of the motorboat will decrease by that amount. So v minus u is the speed of motorboat when moving upstream. So now if we just look at this geometrically, what do we see? We can write this as AC equal to AB minus BC. And for a moment, let's consider the speed of the motorboat alone. So what is AB? This is the distance the motorboat covered in the time t equal to tau. So what is this distance? We know that distance equal to speed into time. So AB will be equal to speed v plus u, since the motorboat is moving downstream over this journey, into tau, minus BC, which is the distance the motorboat covered after it took a turn, and that time interval is t1 minus tau. So BC is v minus u, which is the speed of the motorboat when moving upstream, multiplied by t1 minus tau, sorry. Okay, let's for a moment t1 minus tau, let's call it t2. So AC is equal to v plus u times tau minus v minus u times t2. Now if we just expand this a bit, it will be v tau plus u tau minus vt2 plus ut2. This was with respect to the boat, motion of the boat. I'm sorry. Oh my god, I'm sorry, I'm using this tablet for the first time. Now let us look at the motion of the raft. With respect to the raft, we know that the speed of the raft is u, because it freely floats with the stream, and we'll consider the speed of the stream to be that of the raft. Raft offers no resistance or no push to change the speed by any amount. So the raft moves from point A to C during the time interval tau plus t1. So sorry, t1, total time interval t1. So what is again, so AC, which is the distance moved by the raft, is equal to speed of the raft multiplied by t1. Now t1 we know is t2 plus tau. Now we have two equations in AC. One is this and the other is this. So if we equate the right hand sides of both these equations, we'll get something like this. So what we'll get is v tau plus u tau minus vt2 plus ut2 equal to this particular expression, which is u t2 plus u tau. Now if we can cancel the same terms occurring on both sides, so this and this get cancelled, ut2 and ut2 get cancelled, so we have v tau equal to vt2, and we can cancel v as well on both sides. This implies tau equal to v2. This is an interesting relationship that we got. Now if we substitute tau equal to t2 here, we get AC equal to u, t2 is tau now, plus tau, which is equal to twice u tau. We are also given in the problem that the raft travels a total distance of L, which is 6 kilometer. So which is AC actually, which is the total distance traveled by the raft. So that is equal to L equal to twice u tau. So this implies that we are supposed to find u here, which is the flow velocity, L upon twice of tau. So this is our answer. You can substitute the values of L and twice tau, L and tau here, to get the answer in numbers. Thank you. Thank you for watching this video. Please let me know how we can make this better. This is my first experience in using a pen tab to create a problem solving video. I hope you like it. I'll try to do this better next time as I practice more with my Wacom Intuos pen tablet. Thanks for watching. Keep learning physics. Bye-bye.